Assalamu alaikum. My name is Shagufta Tanveer, and today I am going to explain how to calculate delta H from the bond energies and the energy profile diagram. This is our lesson 2 of chemical energetics. I hope you have seen lesson 1. We talk about exothermic reactions and endothermic reactions. So, exothermic reaction is where energy is given out, and the products have less energy than the reactants. Combustion and neutralizations are the examples of exothermic reactions. When we have to draw its energy profile diagram, so let's see, reactants are at the higher energy level while products are at the lower energy level. We have course of reaction or reaction progress on the x-axis, and we have energy on the y-axis. The difference between the energy of reactant and product will give us the delta H value. For exothermic reaction, delta H value is given out. So we can say that energy released is more than energy absorbed. And if we have to explain in term of bond formation and breaking, so we can say that energy released in bond formation is more than the energy absorbed in bond breaking, because whenever the bonds are broken, energy is absorbed. Now, for endothermic reaction, we know that energy is taken in, that is, the temperature of the surrounding will be decreased. Products have more energy than the reactant. Energy is taken in from the surrounding, it means that the temperature of the surrounding will be decreased. Now, if we have to draw its energy profile diagram in endothermic reaction, reactants are at the lower energy level, so they are supposed to absorb the energy from the surrounding. The difference between them will tell us delta H. So delta H is positive here, and we represent it by using upward arrow over here. So if we have to explain again in terms of bond making and breaking, so we say that energy absorbed in bond breaking is more than energy released in bond formation. So what is the difference? Energy is given out to the surrounding in exothermic, while energy is taken in from the surrounding in endothermic reaction. Delta H is negative if it is given in the equation, the negative value, so we can get it that it's an exothermic reaction, while delta H is positive for endothermic reactions. When we talk about energy of reactant and product, so in exothermic, products have less energy than the reactant, while in endothermics, products have more energy than the reactants. Now, if we have to calculate delta H, that how much energy is given out or taken in, then how we can calculate it. So we know that energy is needed to break chemical bond, and energy is given out when the bonds are made. So delta H basically is the difference between these two energies. So in the exam, bond energies will be provided, and you need to calculate delta H with the help of bond energy. So, different chemical bonds have different bond energies. For example, here, three different bond energies are given in between hydrogen and hydrogen. Oxygen and oxygen, double covalent bond is there, and oxygen and hydrogen. So these values are given in kilojoule per mole. Now, it's an energy profile diagram of water formation. So just see hydrogen and oxygen are the reactant. 2 moles of water are required to react completely with 1 mole of oxygen, and 2 water moles are produced here. So we can draw it in terms of bonds. So just see, 2 hydrogen molecules, 1 oxygen, and 2 water molecules are there. Now we put the energies accordingly. Hydrogen bond energy is 436. So we have to multiply it by 2. Oxygen and oxygen only once it's there, only one molecule is there, 1 mole is there. So 498. 464 is the energy in between oxygen and hydrogen. And in water, 1 water molecule or 1 mole of water, we have two bonds basically in between oxygen and hydrogen. So it's 464 and 464. It's 463 basically. 4 times we have to put that value. Now, so just add up how much energy is absorbed. So we add up all the values, that much energy is absorbed, right? And that much energy is released. So if we can see energy release is more, usually the formula is reactant minus product. Energy for the reactant minus product, you will get the delta H value. Or you can see from these values that energy release is more than energy absorbed. So obviously this is an exothermic reaction. So we just subtract the value. It is minus 486 kilojoule per mole for water molecule, right? Okay, so the energy values have units of kilojoule per mole. Energy goes in to break the bond, and energy goes out when the bonds are made, right? And delta H is energy in minus energy out. So this is the way how we do it. So this is all for today. I hope you understand it well.